focusing on building the best algorithm, I think a lot of the value is going to be lost later on when you're actually trying to put this into production. So I think I would start simple. And then if you already have a model, the next stage is to make it a little bit more complicated and then a little bit more complicated.
All right, so hello everyone, and welcome to the AI Stories podcast. I'm Leiser, I'm a data scientist at iWoka, and I will be your host. So today, our guest is Soledad Galli. Soledad actually comes from a biology background, and she worked in academia in Buenos Aires and in London until 2015. After that, she worked at a few companies like Zopa and LV Equal, where she built machine learning models for credit risk and fraud detection. But currently, Soledad is actually self-employed and she focuses more on teaching data science. She created a few courses on feature selection, feature engineering, deploying model into production, and she also wrote a few books. She also founded Training Data, a school with intermediate and advanced courses on data science and machine learning. So if you enjoyed the episode, subscribe to the AI Stories YouTube channel and leave a 5-star review. Let's start the episode now. Hi Soledad, how are you? How is it going?
Hi Neil, I'm well, thanks. How are you?
Yeah, all good. Good weather in Paris. Everything is going well. So yeah, what about you? You're in Berlin, right?
Yes, I'm in Berlin. Good weather as well, very sunny today.
Great time to record an episode, although we're inside. So
Yes.
so yeah, first question, first thing I want to ask is, I mentioned you come from a biology background. So how did you actually get into the world of data and AI? How did you make this transition?
Yeah, that's a good question. How did I make the transition? In biology, we have quite a bit of mathematical background because we learn about analysis and algebra and so on. But what I did not learn is how to program in any language, let alone in Python or R. So I had to basically learn everything from scratch. And the way I did it is utilizing online courses, the ones that you can find in the biggest MOOCs like Coursera, edX, and Udemy. And that's pretty much how I entered into the field. I took various courses, I did exercises, I joined data science competitions to try and get the handle of it. And then I started applying for positions. I got a few interviews. I started to get a feeling of what you need to know to kind of succeed in an interview. And then I joined the first company. And from then on, I have to say it was uphill because once you join a company and recruiters think that you are experienced, then basically the offers start showering on you.
When did you start this first course? Like, how does it happen that suddenly you're like, okay, I've done biology all my life, and now I want to take a course in machine learning and or data science?
Yeah, it was a bit of a process because at some point I realized that I didn't want to stay any longer in academia. I mean, I enjoyed the analysis, I enjoyed thinking about problems, designing hypotheses, put them to test, but I didn't particularly enjoy doing the experiments myself. What I liked the most was analyzing the data. And I had a little bit of experience with programming because to analyze images we use MATLAB, but I used it very little. I mean, I almost didn't know what I was doing, but I realized that I liked it. So then when I decided I want to basically leave academia, the main question is what do I do with a biology background? Because most of my colleagues, what they do is they go into a pharmaceutical company. But I didn't want to go to a pharmaceutical company. I was tired of doing experiments, so I wanted something else. And because I knew that analysis is what I liked, I started browsing the kind of jobs that were out there, and data science and machine learning was and still is super trendy, and it caught my eye. And then I found out that several colleagues that were also academics have done postdocs, even like me, like they were a long time in academia, were now data scientists. So I started to see that my colleagues have done that transition. So I said, okay, maybe I can do this transition as well. So I contacted a few of them. I asked them. Some of them have like an easy path if you want, because they studied physics, and then with physics or with engineering, you have stronger mathematical backgrounds and maybe some contact with programming. But they said, look, the majority of people are doing online courses, so why don't you take a few of them and see where they take you? I was skeptical at the beginning because I said, come on, like I studied 5 years at university, I did a PhD, and now you're going to tell me that with an online course, I'm going to make it. But the truth is, to my surprise, yes, it works. I mean, some courses are really good, and this is practical knowledge. So once you learn it, you can apply it. So then you really incorporate it. And yeah, that was it. That was my transition, if you want. Like I spent a couple of months trying to see what I could do next outside academia. I discovered the field of data science. I approached some people. They told me to try these courses. I gave it a go. And the whole process took me like 6 months from the moment I kind of make the decision until I start learning with these courses, start interviewing, and then I finally land the first job. It was 6 months of experience, so it was quite fast.
Was this transition difficult? Because I know a lot of people who come from a computer science or engineering background, like myself, and it's usually the same kind of analysis. But coming from biology, do you think that was the transition was more difficult, or with online courses, anyone could really get into the field?
I think with online courses, I wouldn't say anyone, but many can go into the field. I don't think you need to have like a super strong computer science background to go there, because the courses are tailored to a layer audience, if you want. So like they are not designed to target mathematicians or computer scientists. They are designed to target professionals or students in early stages, and they give you a very good intuition of what the math behind the algorithm is doing. So even if you don't remember how to multiply matrices, you can learn it and you can get the intuition. So then you are resourceful at the time of creating these models. I mean, of course, if you have the background, it helps. I'm not going to say otherwise, because that is true. But the courses are very good at teaching you the intuition and giving you the tools so that you can basically take a problem from A to B and resolve it by yourself. So I think yeah, I don't think you need to have a mathematical background or a computer science background. Was it difficult? Yes, but in other aspects. First of all, I thought I would never be able to step up of academia. So if you want, it was difficult in a mental state, because I said, like, I've been doing experiments with cells all my life. Who is going to hire me to analyze credit data, for example? Like, who am I going to convince? And yet I knew I could do it, right? Because statistical tests are the same. Either you apply them to cells or you apply them to credit data, but the test is the same. So long as if you know the test, that's it. You kind of have the technical tools to resolve the problem. Then the only thing that you need to know is a little bit of the background of the problems that the company you're going to work with are interested in. So that was difficult. Like I felt that it was going to be mission impossible. But as I said, like once you manage to convince one company that you can do it, then it opens the doors and you don't have that problem anymore. So that was the first thing. And the second thing is a little bit because I studied biology instead of computer science, and also because I am a woman and women tend to be more insecure, I had a little bit of an imposter syndrome, like on top of of that was telling me, oh, you're not good enough, you're not going to be able to make it, and so on. But yeah, I think eventually it dissipated.
What did you tell yourself, like you to keep going and to get into the field? I guess you applied for a couple of jobs and you got some rejections, or while you were preparing for the jobs, you thought, oh, maybe I'm not good enough. So, what did you do to keep going?
I guess short answer is I just kept going because I mean I wanted to get out of academia and I wanted to be a data scientist, so there was no other choice for me. But on the upside or the more promising side, I was talking to recruiters that told me that this is what people do to land data science jobs. So like if I kept at it, eventually it will happen. And I was also seeing that some colleagues were getting jobs. So like if they were getting it, why am I not going to get them? So it was a matter of time and a little bit of perseverance.
Okay, no, I see. Yeah, that totally makes sense. And so you, after academia, you actually moved, you worked in industry. I think first you had a job at Capgemini, if that's right, and then you moved to Zopa. Is that correct?
Yes. Um, yes, that is
Yeah, I
correct.
just want to focus on Zopa. I'm interested in what you've done there. Obviously, I work at iWoka, so we're also lending money. I think Zopa is maybe more focused on peer-to-peer lending. But yeah, first of all, what's Zopa? What's the company doing? Yeah, can you give a short introduction for people who aren't familiar with the company?
Yes, at the time that I worked there, Sopa was a peer-to-peer lending company. This means that they were not a bank, they were an organization that basically took money from people and lent it on to some other people. And the advantage that that has, at least at that moment, is that if you remove the intermediate banks, then you can give bigger returns to investors and offer lower interest rates to people that want to loan money from you, want to borrow money from you. So that is a peer-to-peer company. And what I was doing there is I was part of the risk team, the credit risk team. So I was building the credit risk model and also the fraud detection model.
Can we talk a bit about the credit risk model? Like, what does it mean to build a credit risk model? And on a high level, what is it? Like, how does it work?
Credit risk models basically assess the probability, if you want, or the likelihood that if you lend money to someone, this person is going to be able to repay the debt that they acquire. And the way you build the model is there are some credit information about people. If you engage in any banking transaction, like basically if you have a bank account, then there will be credit information from you that is recorded and stored by credit agencies. And as a credit company, you have access to this information if you pay, of course. So you can retrieve this information from people, and based on this, you are able to assess if the person will be able to repay the money and how likely it will be. So that is in essence a credit model. So then from the machine learning perspective, it works more or less like any other traditional machine learning model. You have a bunch of variables and you pass those variables through a model, and then you will obtain probability about the likelihood of repayment.
Did you at the time use more interpretable models, or do you use more black box models? Because finance is quite strongly regulated, and I guess you need some understanding of why your model is declining someone for a loan, right? So what kind of models did you try?
Yes, I actually gave a talk in PyData in 2017, I think, where I describe these models that we use. So if someone is interested, maybe they can check that one out. But we were building gradient boosted machines. I think that was the main, if I remember correctly. And yes, I've heard from colleagues that if you work in finance, because it's highly regulated, people most likely want to build linear models. That was true, was not true for us because we were basically a technical company. So I don't know if it's because we had more expertise or we understood the models better or whatever, but we were fine with using more complicated models, if you want to call them complicated, because the truth is you can still explain a gradient boosted machine and you can still explain random forest. So this myth that you can only explain linear models is just a myth. With the technologies that we have today, we can also explain other traditional machine learning models. So yes, the explainability was an issue. We needed to be able to tell why we reject a loan, but we can also do that with decision tree based algorithms. So that's what we did.
What kind of technique did you use to explain the decision? Like, did you use some kind of feature importance or Shapley value or?
Shapley values was not so popular back then, or at least the package that you can use now, it was not widespread. So we didn't use Shapley values. We used feature importance and shuffling of the features. Now you can use Shapley values, but there are also packages that you can use to basically navigate the decisions of the tree. So you basically, if you are you take an observation, like a customer would be now, and then you basically follow the path of the tree. And then with that, you can say, okay, for this particular person, it has these characteristics. This is how the features basically made the tree, if you want to make that decision.
What are the challenges when you build a credit risk model? Um, what kind of challenges did you encounter when building one?
Of building credit risk models, I'm not too sure about the challenges.
Sorry. One thing that I find difficult is the feedback loop. Like in credit risk, when you when you lend to someone, you only realize whether they're going to default or not a couple of months later. So is this something that you found quite difficult? That's it's quite risky, right? Because you implement a change to your model, and if you mess up, you don't realize a couple of seconds after that your model is wrong. You realize this a couple of weeks or months later. Is that something that you experience sometimes?
Yes, that is true. Now that you mention it's the thing that you create a model and then you actually won't know how well it's doing like until 3 to 6 months from now. That is a reality. Probably that's why you spend a huge amount of time into validating your model in historical data. So yeah, that's certainly there. I think also like when you work with credit data, like the amount of information that you can get is astronomical. So try to decide which are the best variables
Mm-hmm.
to build a model that is small and interpretable enough. It's also a bit challenging, like feature selections aspect if you want, and also the feature engineering aspect, which is basically what took me to then create the first course, how you preprocess the variables that you get from these companies, from the credit agencies, in order to be able to use them to train your models.
So do you think that preparing the
Yeah.
data is like a very important step in the machine learning pipeline?
I think that's the crucial step, data preparation, if you ask me, more important than anything else, because the data needs to be representative of the problem that you want to address and the population that you want to address. So this is key. And we did spend like huge amount of time thinking about what data set better represents the customers that my organization is going to serve. And actually, this is a huge issue because there are a lot of problems with algorithms that are biased, not ours, but in, or maybe ours as well, and I don't know. But like there are always more and more stories about algorithms that are biased because they are trained on a very small sector of the society, if you want, and then we use these algorithms to recognize the entire society. I mean, there are movies in Netflix that we can watch about how basically models to recognize faces are trained on white people, and then they are used to recognize everybody, and then they have like a horrible performance in people of color. And the same is true for pretty much everything, including finance, including insurance, including everything else. Like getting a representative sample of the sector that you want to serve is kind of key. And then, so that's the intellectual kind of part, if you want. And then collecting the data from the different data sources is also tricky, or is, yeah, it kind of depends on the systems that you have built already. And with credit agencies, it's fairly straightforward because they've already created the API. So you make a call to their APIs and then basically return the data. But if you want to return data from various services in your company, say once I moved on to the insurance company, and then the infrastructure is not very good, you kind of struggle to get the data together to be able to build the model and then to be able to serve the model. So the problem is it has two sides of the coin. So like how do you get the data to train the model, but then how do you get the data to actually pass to the model so that it makes the decisions in real life?
Yeah, I believe you've also done a course on that, right? I mean, more deploying models to production.
Yeah.
So yeah, you mentioned you worked at another company. Can you talk about this company, LV Equal? Why did you move from Zopa to LV Equal, and what did you do there?
Yes, I think I moved because this company was a bigger company. It had more products, and therefore it had more opportunities to apply machine learning. I mean, SOPA, it was a peer-to-peer company, so it had very restricted amount of use cases where you could do machine learning. So after I built the credit risk and the fraud model, I felt that there was not much else for me to do or to learn. So I decided to change into this other company because there were more opportunities to learn how to apply machine learning in different scenarios. So it is an insurance company, and yeah, like again, the first model that I worked was to prevent fraud. It's a different kind of fraud, completely different from what you see in finance, but it was nevertheless like super interesting. And then you can also build models to basically assess claims and kind of decide or try to improve or smooth how these claims are going to be handled in the company. Like what's the fate of the claim, for example.
Can we dig into this fraud detection? Like, what does it mean to be a fraud in your company? What does a fraud even means?
In insurance, super cool. I had no idea when I landed the insurance company myself. It turns out people stage car accidents so that they can get money from the insurance company. And I didn't know, but this is actually super common. It's also features in Better Call Saul, if you like that series. People drive their cars and then they basically brake, and the one that comes from behind hits you, and then you basically claim that you have like neck injury, and because the soft tissue doesn't really appear in any x-ray or anything, it's very difficult to refute, and then basically the company has to pay because it has no way to say, oh, you staged it. Or so yes, I didn't know, but it exists. And then you can actually find videos on YouTube of people staging car accidents. So I find it crazy. It's really crazy, but it exists. So fraud in insurance, in car insurance, means staging accidents to get the insurance company to pay, basically.
Oh, that's very interesting. I had never heard of this. So they make an accident on purpose and then pretend that, yeah, they've got some soft pain to claim money from you.
Yeah. That's it.
And so you managed to use machine learning to identify them? Is that what you were working on?
Yes, yes. Basically, you take the circumstances of the accident, which are described in the claim, and those will be the features to your model. And based on the circumstances, you can actually predict the likelihood of this accident being fraudulent or not. Of course, it's a very, very, very tiny proportion of the whole claims that you get. So that's one of the challenges. If you want, is you have a very, very small sample to learn from. Um, yeah.
Yeah, one question on this is how do you first you need to label your data, right? So you need to look at historical data and say, okay, this person was a fraud, this person wasn't a fraud. So you need to identify frauds. How do you know if, like, for example, for this, how do you even know if someone lied or if they're just really injured? How can you distinguish and make sure, okay, this person for sure it's a fraud? Because in finance company you can lend money and you know if someone doesn't repay you, you know it's a fraud, right? But in your case it's much, yeah, much more difficult to identify, right?
Yes, exactly. And that's challenge number two. So basically, if you suspect it's fraud as a company, you can dispute. And then most likely, to be honest, I don't know the entire process because I wasn't in charge of that. But from what I remember or heard, is like the company engaged in some sort of litigation, and then you have to gather proof that supports the fact that this claim is fraudulent. It may go to court, and then if the court decides that you as an insurer are right, then you can label that as a fraudulent claim. But if the court decides that it's not fraud and then it was fraud, you will never know. If you don't have enough evidence to prove if it was fraud and you suspect that it's fraud, you never know. And then there are also a lot of cases that you just don't know. So within your data set, it might be, and I don't know because, as I said, it's not possible to know that you have circumstances that are staged, but then you will never know. So you count them as normal claims. So that's also an interesting challenge.
Do you know, I'm just interested, how much one fraud could cost to the company? Like how much money can I get from you if I pretend that, yeah, I've got a neck pain or something? Is this a lot of money? Or
Yeah, it is a lot of money, but I don't know the numbers.
okay, but it can be quite a lot.
Yeah. I don't know if you can actually search this information online. Yeah, I could do a quick search and have a look.
Yeah, I can have, yeah, no worries. I can look and maybe share the information if I find it after this episode. And another question that I have, because I'm not very familiar with fraud detection, you mentioned that one challenge is to deal with imbalanced data, right? Like you have a little bit of frauds and a lot of customers who aren't frauds and are just really claiming money for their car accident. So in machine learning, we need a lot of data, right? And if you've got just a little bit of frauds, it will be very difficult for the algorithm to identify them. So what do you do to deal with this imbalanced data set of a little bit of frauds and a lot of non-frauds?
From a technical perspective, you mean? I think there are quite a few methods that you can apply to work with imbalanced data. There is one that you could do if you have huge amount of non-positive cases is that you undersample one part of the data set. You can also oversample the fraudulent part. You can create synthetic examples. So there are algorithms that take the pool of fraudulent cases, and then they create more observations that look like those fraudulent cases without necessarily repeating the observation with duplication, which would be what you would do if you just oversample. The most famous one being SMOTE for synthetic minority something. Yeah, I don't remember what it stands for right now. So those are some of the things that you could do. I mean, of course, they have some limitations because they're based on nearest neighbors, and nearest neighbors algorithms are not scalable, but for the amount of data that you have in an insurance company or a finance company, I think those models are good enough. Then there are also ways in which you can force your algorithms to focus more on the minority class by assigning weights to the calculation, to the misclassification. And this is by basically correcting the optimization formula, which sounds difficult, but you can do it like fairly straightforwardly with scikit-learn. It does it out of the box. You just need to basically provide the penalization or the costs, if you want, of misclassification. So those are the main ones, the ones that we used because they are basically ready to be used. Then there are more complex algorithms that with ensembles, especially tailored for imbalanced data, but I have not used them. I have to say, I think it overcomplicates too much. And it's when you work in a company, it's very convenient to use open source libraries that already have everything implemented, because then when you deploy, you basically don't have to write code. You just deploy and take these algorithms from the library. If you want to use something special, then you have to write the code in your training environment, and then you basically have to deploy that code, and it's a lot of work. And I mean, unless it brings a huge increase in the detection capability of the model, it's not worth it, I would say.
So two things to say based on what you said. First, if I understand well, there are two kinds of ways to deal with imbalanced data sets. One way is like you play around with the data, so you undersample the majority class, you oversample the minority, or you create synthetic data. And I guess once you've processed your data set, you could just use traditional algorithms like decision trees or regressions or whatever to deal with the problem. And the second kinds of models are models that are basically created to work with fraud detection or imbalanced data sets. Those are kind of the two different ways you can deal with fraud detection. Is
Yes,
that right?
and yeah, those are two ways. And then the third way, I would say, is to modify the optimization algorithm by introducing a misclassification penalty, in which case you will also be using the traditional machine learning models. You will not be modifying the data, so you will be training it on the imbalanced data, but you teach the model that making the classification of the minority class wrong costs 10 times more, 100 times more than misclassifying the other observation. And this way you force the model to pay more attention to this minority class. So it's three ways, basically, of handling imbalanced data. So you either modify the proportion of minority class, or you use these special algorithms, or you modify the optimization of the optimization of the traditional machine learning models by introducing costs to the misclassification.
Yeah, that makes sense. And so when you started the project, did you start from scratch? Like, did the company didn't have anything, and you built an algorithm to solve this problem, or did they have a model that you had to improve?
Yeah, insurance company have existed way before machine learning came to the world. So they, of course, they have the systems in place. They have rules systems, or in the finance company, they also have like linear models. So what I did, if you want, is to use decision trees based on the same features that the company was already using with rules and with other systems. And did I start from scratch the model? I would say yes, but I mean, I landed in a group of experts that knew what they were talking about. So like the people were, it was amazing in the sense that I can provide the technical expertise and then they can provide the product expertise. And between the two of us, we can come with this project that is, yeah, that's makes it fun basically because we both learn from each other. And it makes it better that if I am basically going in the darkness, trying to understand what feature can be predictive and why. I mean, I say, oh, this feature seems cool. And then they say, oh, yes, we know already because, we've been doing this for 50 years. So it makes sense. It helps you validate the model. And then maybe sometimes the model says, oh, actually, I found this that is cool. And then say, oh, I didn't know this. And then, you give them more elements to work the cases.
That's something I think very important when you work in industry. Like, you should know as a data scientist that you should communicate with experts. Like, some people are experts in their field and they would know much better than you which features you should use in your model. And so it's super important to talk with them and understand what features you should build. Like, we do that as well in credit risk. I'm not an expert in finance, and I'm not an expert in what would make a company default or not repay. And if you talk with credit analysts who are actually the experts, you can make progress much faster than if you just work alone. So is that something that you also noticed when working in industry? Communicate with experts is very important.
Yes, I think it's key. It makes the job easier and also more fun because, I mean, when they have this background knowledge or this domain knowledge and you come up with this feature, I mean, it's very difficult if you go in the company 1 year and then you want to understand the whole financial ecosystem. Like I don't know. I mean, I'm not saying that it's impossible, but it's hard. And people that have been working there for like 30 years, I mean, they have like they know what they're talking about. So it just helps you grow and develop the products much faster. And also it's fun when you just take one variable and you can build a story out of it with this team.
The other thing that you mentioned earlier that I think was also interesting is the fact that you could use those ensemble, more complex models, but they require more time. They require you to code. You can't use them out of the box. So is that something also quite important in industry? You don't really need the more advanced models. You need something quick that works well. And if you can use something out of the box that works, just be smart and use those solutions instead of reinventing the wheel and coding an algorithm from scratch, or modifying an algorithm.
Yes, I think that is true for a lot of companies and a lot of organizations and a lot of circumstances. I think a simpler solution will capture 90% of the problem. It might not be the best one, but building the model is a very small aspect of all the things that need to fall into place so that you can actually use that model. Because then you need to manage to get the variables through the model, which is already a problem, and then serve those predictions. And then at the back of those predictions, you're going to do something. You're either going to reject a loan or send a claim for further investigation or wherever. So it's a huge process, and there's a lot of additional variables that are going to impact on the fate of whatever your algorithm is trying to do. So focusing on building the best algorithm, I think a lot of the value is going to be lost later on when you're actually trying to put this into production. So I think I would start simple. And then if you already have a model, the next stage is to make it a little bit more complicated and then a little bit more complicated. But that would be secondary if you ask me.
Yeah, I completely agree with you. I think those incremental improvements are super important. Like, once you, if you don't have anything, just build something better, deploy it in production quickly, and then you can iterate and get an even better model and try something more complex. But yeah, try incremental improvements, because the risk is also, if suddenly, let's say you wait 1 year, you build a super big model that's going to be really, really good, you you lose 1 year of value, right? Because during 1 year you haven't deployed anything in production, so you're losing value. And the second thing is, you have a really big model that's replacing nothing. There are so many things that can go wrong, right? Because that's a massive change. Whereas if you just build something simpler and then you build on top and then you build on top, you've just got less risks, because you're just making some small improvements which are much less risky than just 1 year of work and then deploying a big new model in production.
Yeah, absolutely. And also in the exercise of putting a model in production, you are going to learn a lot about the challenges that you're going to face. So then you can actually also improve on those challenges and you can anticipate to the challenges that you're going to encounter looking forward. So yeah, I think yeah, I totally agree with what you said.
Yeah, very, very good point. Last question on fraud detection before we move on to teaching. Do you remember the improvement that you made using machine learning? Like, what was, I don't know, the accuracy or whatever of your model before using machine learning and after? Or by what percentage? How much better is machine learning compared to a simple rule-based algorithm, if you still remember or have a rough idea?
No, to be honest, I don't remember because it was many years ago. But even if I remember, I'm not too sure I'm allowed to disclose those values. But yeah, no, I don't remember is the short answer.
Okay, so I guess that's a sign that we should move to the teaching part of your career. So yeah, let's move to that. You worked at various companies, you built credit risk models, fraud detection models, and then at some point you decide to focus on teaching. Why do you decide to move? You've done everything, right? Academia, then industry, and now back to teaching, but online. So yeah, why did you move to teaching?
Um, it was a progressive transition. It started with so I've learned from courses online. I managed to get a position, and then I have to tackle my first problem. So I have to build a credit risk model. And I was like, the variables, they are not ready to use. Like you can get them from a data science competition. The data is super dirty. What do you do? Wow. I had no idea. I mean, of course, there were systems already placed, put in the company because I didn't build the first model. So someone else built the first model. I built, if you want, the second one. So I've learned a lot from that. But I realized that there was a gap between what you learn in these initial stages machine learning courses and what you're actually going to be doing in a company. And because I mean, depending on the platform that you take courses, sometimes they come from universities, but if you take them from Udemy, they come from professionals that basically are at the front line, if you want. And I thought, I mean, if these people helped me get a data science position, can I not help others basically improve their skills by teaching what comes next, like basically filling that gap that I saw between first stages or beginner courses and what you're actually doing when you work in a real use case. So I said, I'm going to give it a try. I didn't know if it was going to fly or not back in the day, but I took it as an exercise, a little bit of a hobby. And I created the first course, which was feature engineering. And it was very well received, actually, because at the time, there was nothing like it. I mean, most courses were about machine learning, programming in Python, data science, like general exploratory data analysis, but they were not intermediate courses at all. So it was very well received. And then I decided to do the second one, which was feature selection, is what comes after feature engineering. It was also well received. Then I managed to get my colleague excited. I mean, my co-instructor in the deployment model was actually my colleague in the finance company. So I was building the machine learning models and he was deploying them. So we worked a lot together and said, okay, why don't we team up and create the deployments course? So we did that. And then I discovered that it was fun and people were really grateful of these courses. So I started making another course and then another course. And then eventually I could make a living out of this. So I decided that I would do just this for various reasons. First, it's like super rewarding, and also like basically being self-employed means that you administer your time the way you want, so you can work whenever you want from wherever you want, which it's priceless if you ask me.
Yeah, yeah, I agree that that's a good point. That's why did you move to Berlin then, or you've always been in Berlin?
No, I moved to Berlin 3 years ago. I was like 10 to 12 years in London, I think.
Nice, nice. So yeah, so what do you like so much? Is it the first of all, is it because you're learning a lot when you're teaching? Because I guess you should be learning quite a lot by reviewing the material or going deep into it because you really need to know what you're teaching. I mean, when you obviously when you build a model while working, like you know what you're doing, but in a class it has to be clear, it has to be well explained. So I guess you really need to know something deep, deep at another level. So is this part, and I guess you also mentioned it's super rewarding. What do you mean by rewarding? Is it the feedback from students? Is it yeah, that you're happy to complete a course? Yeah, can you touch on this, please?
Yeah, it's a little bit all of that. I mean, if, what I like so much about teaching, I could be talking hours about this. First of all, yes, as you say, the learning curve is fantastic. This is where I learned the most. I mean, when I first started data science and I got my first job, there was a very steep learning curve there, so it was exciting. But then towards the end, the learning curve kind of flattens because you reach the level where you know enough to tackle more or less all the problems in the company. So you don't learn so much anymore. At least that's how I experienced it. But with creating courses, you, as you said, you have to know the subject a lot because you need to be able to explain it, and it needs to make sense to me so that I can make it make sense for others as well. So yes, I really need to know the ins and outs of what I'm trying to communicate. So the learning curve is really amazing. I've learned a lot and I continue to learn. And even as I update my courses, like now, for example, I wrote the second edition of the feature engineering book, and I've learned so much, even though I just was updating the chapters that they were there already. And like as I update the chapters and I learned so much, I was like, oh my God, how did I manage to write this book 2 years ago? Because now I know all of this, and now I feel that I'm suitable to write the book. And I'm pretty sure that, when I update this book in the next time in 2 years, I'm going to have the same feeling. So yes, it's a lot of learning. So that's super cool. The students, I find that they're really grateful and they let you know that how you've helped them. I get comments on the course platforms or also on LinkedIn saying, "Oh, Sole, your courses helped me to do this." Someone say, "Oh, I could land a job because of your courses. Like I was able to manage to answer this and that question in the interview. Oh, your course helped me to resolve this problem." And also, like I have an open source package now. Well, now the open source package has like 2 or 3 years now, but more and more people are using it. And I get also a lot of feedback about how this library is basically help them engineer and select features for the use cases and their data sets. So yeah, in a nutshell, that is it. Like the impact that teaching has is so tangible, and is, at least for me, it's an amazing feeling to feel that, yeah, like I'm supporting others fulfill their goals. through my courses. I guess those are the two main ones.
No, that's I'm just wondering because there are so many data science, machine learning courses out there now. I guess when you started, it might have been um, rare, but now online teaching is very popular. So, what makes your platform? You founded Training Data, right? What makes your platform different than others? And also, how do you decide which courses you're going to create? Like, why feature engineering, feature selection? You created a new course on feature engineering for time series forecasting. So, yeah, how how do you decide which courses you're going to create and how do you market them to make sure that people actually do them?
Yes, so I try to focus on courses that don't exist already, uh, because basically that brings something new. Like as you said, the online teaching has exploded, and now there are a lot of platforms and a lot of courses. So I would say that perhaps the courses that will help you give the first steps in data science, that is a little bit saturated, if you want. But after that, it's still little. So most courses focus on trying to help beginners, to say it somehow. I guess it's because there's always going to be more beginners than intermediate people. So that's why probably most platforms and most instructors try or prefer to focus on that. I think otherwise. I think that it's also, I mean, so I try to fill the gap, as I said before, between, okay, so now you know machine learning. So how do you do it in the industry or in a corporation or in an organization? So I try to fill that second step, if you want. So like this is how feature engineering was born. Now there are a lot of courses on feature engineering. I would say that no one is as extensive as ours. Most of them teach the very basics, like imputation with the most basic algorithms, one-hot encoding, ordinal encoding, and how to transform the variables, and nothing else. We try to give a broader view of all the possible things that you can do. So to empower people to make decisions on how they want to pre-process their data. So yeah, basically, I take a little bit from my experience when working, like what would I what would I have liked to know when I was first working on my projects? I would have liked to know more about all these topics. So then this is how I decide a little bit what to teach. And at this stage, students basically asked me if I could make a course on this or that because they feel that they are struggling and the space is not well served. So and at this stage, it's a combination of both things.
So if you're a beginner, let's say I'm a beginner just starting in data science and I want to get to the next level, like intermediate or advanced data scientist, which courses would you recommend me to take, or what should I do to go to the next level?
I think it's I think it, so different people would call beginner different things and different sets of skills. So I don't know if there is one way of answering that question. I think it kind of depends what you know and where you want to be. I mean, I think in general terms, the first thing to learn is how to program in Python or R, how the machine learning algorithms work. I would argue that you would be more resourceful if you really know what the algorithm is doing, even if you don't know or if you don't remember how to make matrix multiplication or how to make derivatives. I don't think that's important, but I think it's very useful if you really understand what the algorithm is doing and how the algorithm is making their decisions. So I would spend some time there as well. And then I would try to understand, so data preprocessing is key, data analysis is key. So how to basically analyze the variables. How do I know that these variables make sense? They are predictive. How can I transform them to use them in machine learning models? How do my transformations affect the model? I mean, because some transformations are suitable for some models and not for others. So the fact that now everything is open source means that I can do a lot without really understanding what's going on. I may be lucky and I get a good model, but if the model is not good enough and I don't really know how my transformations are affecting the model, then basically I have no tools to try and troubleshoot that. So yes, that's it. So once you have the basis, go deeper and deeper into all of them.
Yeah, no, that's a good advice, I think. And yeah, I guess it's a quite a broad field, though. So there are so many things you could learn. I guess it also depends on what you're interested. If you're interested in computer vision or in NLP, you could go deep in there. Yeah, it's quite a broad field.
Yeah, that's the thing. And I'm also very focused on Python because I mean I have fun and I like it. But if you're working with like astronomic data sets, then maybe you need to learn another tool like Spark, for example, which is completely alien to me. But it could be useful in a different set. So I think the possibilities are endless, and I think you could take it either way you like.
No, yeah, that's a good advice. I want to focus now. Well, just two questions basically on your career before we finish the episodes. The first one is I just wanted to know if you remember some mistakes that you've made in your career or things that you would have done differently, looking back from where you are now, things that you would have done differently, related to data science, machine learning, or related to your career in general?
To my career in general, if this was one thing that I would have done differently, is I would have left academia like 5 years before I left it. That's the number one mistake that I made. It has nothing to do with data science, though. Yeah, I
Why would
haven't thought
you
about it. So I don't know. I
why
mean,
would you have left earlier?
because now, when I look back, I realize that the progress that you make in academia is super slow, and the impact that I made as a scientist, I'm going to talk for myself, even though I would think that this is more than just me, is minimal. Like I felt that my work in academia, in comparison to the things that I do now, have like very little impact. And I'm not saying that you cannot do important things as a researcher. I think you do. But I also think that it could be improved a lot. I mean, I think the academia could move faster and it could optimize their processes to have a greater impact in the things that really matter. So I guess that's why. And also, like, career progression in academia is like super slow. You spend 4 years doing a PhD, then I spent 10 years doing a postdoc, and I was basically going to die there unless I wanted to go to like a small city in the middle of nowhere where maybe there was a position for me to become a principal investigator. And so it's a bit depressive, if you ask me. And when I stepped out, things move much faster. It's more dynamic, and then that makes it more exciting, at least for me. And the impact that you have is more tangible, like a teacher, or even when you field finance model is actually being used. Fraud models are actually being used, and you can see how they are making impact pretty much in real time, and that's I find super rewarding as well. And also, like, the pace of learning in self-development is huge outside academia, at least for me, compared to when I was there. So to me, it's all these pluses.
Yeah, it looks like you're interested in two things: learning fast, you really like that, and having big impact. Is that right?
Yes. In a nutshell, yes, I think so.
it's important for you to have a big impact. That's what you do. What you do.
It's not just, yes, it's not about having a big impact from a narcissistic point of view. I mean, I think fossil fuel companies have a big impact, and it's not necessarily a good thing. I think it's about, for me at least, try to help others in any way, which through teaching you can. Like, I felt that the online courses helped me, so I can see how that can help others. And also with software, like as a data scientist, I've never coded an algorithm myself. And this is because the developers of scikit-learn take care of this already. And this library is being used worldwide across organizations. So imagine the impact of this team of developers on the world, if you want. And yeah, through open source, you basically having an impact in the sense that you are trying to help others, organizations, people make their job easier. And that's the kind of impact that I want to have, if you want.
Cool. So let's finish with one advice. If you just had one advice for someone to progress in their career, what would it be? Just one.
Learn a lot and persevere, stay at it, and they'll make it.
Cool. Thanks. That was short and precise. Thanks a lot, Soledad. It was great to have you here on the AI Stories podcast. Yeah, have a great day and hope to see you very soon. I will put in the comments some links to training data and to some of your courses. I actually took one class on model deployment, which was really, really good. So strongly recommend your courses. Yeah, and I will include some links. But yeah, thanks a lot. Have a good evening and hope to see you soon.
Yeah, thank you, and thanks for having me here.
No worries. Bye.
Bye.